Welcome back to Encrypt Coding YouTube channel. Hello everyone. So today we'll be discussing about introduction to functions, and this is part of our Java series. There'll be many more videos like this. So please like, comment, share and subscribe. So at the end of this video, we'll be learning how to understand the purpose of a function, define a function, pass data into a function, return a value from a function, and execute a function. Now let's get into the video. Now what exactly is a function? A function is simply a set of commands or a set of statements in the form of code, which makes it easy for the programmer to conduct a certain task in Java. It's also known as a method. So these are a group of code which are collected together to perform an operation. And this function only runs when it is called. An example of a function would be the main function, which is always there in every program. Now you would be thinking, how would the main only run when it is called? Because whenever we execute a program, the main automatically starts. But in BlueJ, which will be the IDE or the integrated development environment, which we will mostly use, how do we execute a program? We execute a program by clicking on the void main button at the side of the program. Therefore, that command essentially tells the computer to run the main program. Hence, the main function only runs when it is called. Now, these can be considered as an organization tool for various classes. Essentially, huge chunks of complex code can be organized in different methods to reduce the complexity of the program and increase the understanding for a fellow programmer. Now, there are two types of functions. We've got the predefined functions, which are within the library class. So these will be discussed in another video. But essentially, they have built-in methods, which have sets of standard pre-tested code to conduct certain tasks. So the programmer need not write specific code for a certain task. For example, these would be operations like finding the power of a number, trigonometric operations, and square root, etc., which requires extensive complex code. Now, other than these functions, we've got the user-defined functions. These we can make by ourselves, by the programmer itself. And in this video, we'll mainly discuss the user-defined functions. Now, why do we need functions? What is the purpose of a function? So the first purpose would be function reusability. So smaller methods can be reused in other programs and other classes. So the programmer does not need to rewrite the code if the same task is to be accomplished in another program. And then we've got coping with complexity. When programs become long, extensive, and complex, it's a lot better to break down the main method into smaller components, which are the methods and the functions. So these components become easy to manage and maintain. Methods and functions can be created to do one specific action. So these conceptual units make it a lot easier to work with programs, and it reduces complexity for fellow programmers and even the user who sees the program code. And then we've got hiding low-level details. A method hides the complex details from users. Once a method is defined, users simply have to call the method to execute the task, and they do not need to know about the background code. Then lastly, we've got ease of maintenance. Instead of maintaining multiple copies of a piece of code, which is to be used in several applications, it would be a lot better to store only one copy of it as just one method. This would be easier to maintain, because if there are any errors or any changes need to be made for the code, it does not need to be done in multiple copies. You only need to do it in one copy, which will be in the method, and that revised copy would be called to all the different classes and applications. Now, how to create a function? So a function essentially has two parts, which is the function declaration. The function declaration is the first line of a function, and it's also called the function prototype. It determines the interface of the function, what parameters go in, and what value comes out of it. We'll discuss what a parameter is later. Now, this function declaration or function prototype, it consists of the function signature. And we'll also discuss what is a signature. Now, within the declaration, after the declaration, there'll be two curly brackets. Within those curly brackets would be a set of instructions, which is a function body. Now, a method is always required to be placed inside any class. For example, the predefined methods are always placed inside the library classes. Now, the structure of the function declaration will be what to discuss right now. Now, first we've got four terms: access specifier, modifier, return type, and parameter list. So now the access specifier can be public, private, protected, or not mentioned. So it essentially specifies who can access that function. Can other programmers access it, or can other classes access it, etc. Now the modifier is static, or it can be non-static, where it is not mentioned. Now, what are modifiers? This will be discussed in another video. Modifiers are a part of object-oriented programming. Now, the return type can be any valid data type, since the function can or cannot return a value. Suppose the function does not want to return a value, the return type can be mentioned as void. Then lastly, we got the function name, which must follow all the rules for a proper identifier name. And lastly, we got the parameter list. And we'll discuss what are parameters later. Now, why do we exactly need functions? So this is an example. We've got the printing of a normal bill. I'm sure all of you must have gone to supermarkets and groceries where you must have been given bills like these. So you've got a line and then the name of the company or the name of the supermarket, and then you got another line and then the location and all of the data, and then the last line after that, the total bill value. Now, as we see, there are 3 lines to be drawn. So we would need to repeat the same code again and again for 3 times, or it can be even more than 3 times in complex programs. That's where we use a function. So this is the original program without a function. As you can see, the lines in blue, it's the same code repeated 3 times. So there's a waste of memory, there's a waste of space, and it also makes the program code a lot more complex. It just increases the length of the code also. Now, to avoid this and to make it a lot more simpler, we can form a function. So here we've done a function called public static void drawLine, which contains a for loop for drawing 60 dashes, for printing 60 dashes, which forms a line. And then you've got this final println statement to move the cursor to the next line. As we can see, we've got the function definition. Here the public is the access specifier, static is the modifier, and void is the return type because it doesn't return any value. It only prints an output to the user, but it doesn't return any value to the main function. Now, how do we call a function? All methods are called from the main method to accomplish a specified task. Now, why do we call from the main method? The main method is the logical starting point of any program, and each class will always have one main method. Since when the Java compiler is being compiled, it will always search for the main method first to execute the program. When the method is inside the same class as the main method, as you can see, we use the method name along with brackets and then a semicolon. When the method is inside the same class as the main method, as you can see, we use the method name along with the parameter list, or if there are no parameters, we use brackets and then we use a semicolon to call the method. When the method is inside another class and that class is different from the main method which we use, then we use the class name and then we use a full stop, which is a separator or a punctuator. And then we write the method name along with the parameter list and then a semicolon. Now here I've given an example for calling a function. As you can see, there are two classes here, class report and class line. Class line consists the function for draw line, which draws a line of 60 dashes. And in class report, there is a main function. The main function calls the drawLine function from class line, which is a different class. That's why we use the class name, which is line, and then we use the separator or the full stop, and then we mention the function name along with the parameter list. Since there are no parameters in this function, we just mention brackets. One thing to note here is that you can call the function any number of times. There is no limit to how many times we can call functions. Now, this is a code for which I will give you 30 seconds to find the output. And your 30 seconds are over. So the output is what it is given. Gems Modern Academy, welcome to Java. Have fun, bye, and hello students. So what happens in this code? So first the Java compiler finds the main method. Now when you see the main method, it calls the function fun1. Then we go to the fun1 method, where it tells to print Gems Modern Academy. Hence the first line is Gems Modern Academy. And then it executes or calls the function fun2. Now we go from fun1 to fun2. And here it prints welcome to Java. After which it calls fun3. Now when we go to fun3, it tells to print have fun. And since fun3 was called from fun2, the fun3 function ends and then the compiler's cursor goes back to fun2, where it prints bye. And since fun2 was called from the function fun1, it goes back to the function fun1. But as you can see, there are no more statements to the function body. Hence the function fun1 ends and it goes back to the main function, where it prints hello students after the calling of fun1. This is how you get the output. Now we'll go to the main part. What is a parameter? We've been talking all this while about parameter lists. Now what exactly is a parameter? It's a data value, a value of a certain data type that is passed into the function, and the function utilizes this data value to accomplish a particular task. So this parameter is also known as an argument. So as we've seen before, a method can contain 0 parameters. It does not need to have parameters. Or it can have 1 or more parameters. And then there's no limit to the amount of parameters a function can have. There are two types of parameters, and we'll get to this a little later in the next slide: the formal parameter and the actual parameter. Before that, we need to know why exactly do we need parameters. Now, if you want to give a function a value from another function, you have to pass it in as a parameter so that the function knows this piece of data exists and this data can be used within the function to accomplish a certain task. So parameters can be thought of as the bridge between the main program and the functions you create. Parameters are extremely important in complex programs where you can pass data values from one function to another. Now we've got the two types of parameters, the formal parameters and the actual parameters. Now formal parameters, they appear in the function prototype or the function declaration when we actually write the function and the function statements. That's when we see formal parameters. So for example here, we've seen public static void drawLine, and the formal parameter here is int n. Formal parameters can only be variables. They cannot be values like literals, but they can only be variables and they always need to be initialized. They always need to be preceded by a data type specifier. One thing to note here is that it does not have to be a primitive data type like int. Even strings can be passed as parameters along with arrays and objects. So there's no limit to what kind of data type can be passed. Formal parameters can be considered as a placeholder for actual parameters. Now we'll see why. Actual parameters, they come in the function calling statement. So for example, we've given here that the drawLine function, which we mentioned before, has been called with a value of 90. So the int n value will be 90, which will be utilized in the for loop to print 90 dashes. So the length of the line is 90 dashes. And we've also seen that drawLine function has been called again with another value of 25, which is stored in the variable int n. Now this n, which is in the main function, becomes the value in the int n of the drawLine function. So there are 25 dashes printed. Hence, one formal parameter can represent many actual parameters. It just shows that there is a parameter of this data type and the value can be changed as per the user's liking in the program itself. One thing to note is that the actual parameters may be literals or variables, and the variables need not be preceded by a data type specifier. But one thing which is very important is that the formal parameters should match in number, type, and order with the actual parameters in the function call statement. For example, if the parameter list is int n and string s, then the actual parameters has to be an int value, and after that there should be a string value. The order and the number and the type of the parameters cannot change. They have to be the same. Now we go to the return keyword. So the return keyword is mainly used to terminate a function or to end a function. But there is another use of the return keyword. It can be used to send back or return a data value of a certain data type back to the calling function. So such a sending back or return a data value, that only happens when the return type specified is not void. When the return type specified is int or any other data type. Suppose if the specified return data type is void, then we use the keyword return, but then there shouldn't be any data value or any literal or variable after it. One thing to note is that the returned value could be an outcome of an expression or it could be a variable, or it could also be a literal. And a function could have several return statements, but only one will be executed. That's very, very important. Now let's see in the int product. So the example given here, we can see that public static int product. So this function has two parameters and it returns the product of those two parameters. And in the second function, we can see that the product is stored in a value x and the x is returned. This shows that you can return a result of an expression, an arithmetic expression. It could also be in Boolean expression, and you could also return a variable. While in a void function, which is the third example given here, you can see that it can just return without having any data value, but that just ends the function and the cursor of the compiler goes back to the main function. Now, what are the four main characteristics of functions? This is extremely important. So the first one is the function may or may not have a return data type. It may or may not return a value. If it returns a value, it can return only one value of a specified data type, and only one value. You cannot return more than one. The return type must be specified in the function declaration. This is the second characteristic. The third characteristic is that if the function does not return anything, then void will be specified. The fourth characteristic is that a function may or may not have parameters. It depends on the programmer. So that's it for the theory part. Now we have some homework sums for practice. Please take a screenshot if you want and post the answers in the comments below. Thank you so much. That's it for today's video. This is Nandita signing off, and this is the Encrypt Coding YouTube channel. Don't forget to like, share, comment, and subscribe. See you later.